All right. Go ahead and write down this problem. Okay. What we're going to do today is we're going to look at more examples that involve trigonometric functions, as well as some examples of what I call incomplete substitution. Okay. So write down this example. And then brainstorm for 30 seconds how to go about doing this problem. All right, so let's talk about this all together. Part 5. What was your thought process?
We split it into sine or cosine times 1 over cosine and then change that to tangent.
And you changed it to tangent secant? Who did something different? What? U equals cosine. Okay, so watch this. Okay, we have 2 different ways to do this problem. Okay? Some of you talked about, oh, well, we can just use trig identities to change this to secant x tangent x. And Eli, what's the antiderivative of secant x tangent x? Okay? Or if you don't recognize that, not a problem, we can let u equal cosine x. Du would be negative sine x dx. And we now have negative integral of 1 over u squared du. Some of you had a very similar problem today as far as your u substitution is concerned. Okay? Remember, this is u to the negative second. Right? So the antiderivative of u to the negative second is u to the negative first times negative 1. And we have 1 over cosine of x plus c, which is secant of x plus c. Okay? Now, kudos to you if you saw the trig way to do it. Obviously, that's the easier way. Okay? But if you don't see the trig identities, okay, if you can recognize that cosine and sine are related in the way of if we let u equal cosine, our du is going to have that sine of x in it. It's a very straightforward trig substitution, or excuse me, just u substitution problem. Okay? Like I've been saying, the more we see these problems, the more you'll have that vision. Okay? And if you didn't see the trig identity thing, okay, it's okay because I've kind of like brainwashed you into looking for substitution. So that's what I was wanting you to look for. Okay? Let's look at another one. Equally as fun, Eli. Equally as fun.
Sure.
Okay, do we have a candidate for U substitution? Yeah, I don't know if you really want to try. It would be 1 minus sine squared in order to be able to change to cosine squared. Okay. So we have two different groups of trig functions here. Sean, what would we want u to equal? So if u equals cosine, well now I don't know what you
Put
want.
it under the radical.
You want u under the radical?
Yeah, so 1 plus sine.
So now you want 1 plus sine,
Yeah.
which makes du cosine of x dx. And do we have cosine of x dx? We have exactly that, right? This is like the perfect u substitution problem. Okay, when you're looking for u substitution, always look for what is composed inside a different function. Okay, so this becomes the integral of, I'm going to write it as u to the 1/2. Is that all right? Okay, so we can use the power rule. So you get u to the 3/2 times 2/3 plus c. Grace, did you have a question? Okay. Would you be excited if that were a quiz question?
Yes.
I would be excited if that were a quiz question. If I were you, like, that's like the perfect u substitution problem.
Yeah, that was last year.
All right, since we're on our trig, that's kind of what I was gonna say, but I thought you'd make fun of me, so thank you for thinking of it yourself.
Wait, what? I totally missed it.
We're on like a trig train of thought here.
Or respect it.
I got an email from your brother today, by the way.
He needs a letter of recommendation. He made me get on our computer, and he didn't know the password, so I had to wake my dad up from a nap. I just needed my helpings in Lincoln.
Talk at your pod. How to do this? Go ahead and do it if you want.
Stars are so hard to draw.
My pass is gone again, so just grab a
Cool.
Yeah. Yeah. I have like 2 parents, but that's it.
Sorry, yeah,
There's
Flash
like 3
star.
in the flesh.
right over Dylan. Ooh, Dylan, if you're it's an outside thing.
Yeah.
Now it's not because.
I've been playing for the other people.
You don't want any like air inside.
Whoa. Trying to say.
I cried.
It's actually one of
Yeah.
Autumn, what do we do?
Well, I set x squared equal to u.
U equals x squared?
So then it'd be 2x, yeah, but then we want that 2 So I had 1/2, and then I had sine of u, and then du.
All right, this was Autumn's method. Do you agree?
Do a 1/2.
Was my head? Okay, so then we end up with 1/2.
I said negative 1/2 cosine.
Negative 1/2.
U.
So we end up with negative 1/2 cosine of x squared plus c. Okay, I know that this wasn't an overly difficult problem, but we've been on that train of putting u equal to a trig function, right? I don't want you to think that that's always what happens. Okay, we put on something inside of our trig function in order for us to set u equal to.
Figuring out negative.
Because they don't give the negative.
Isn't I thought they were cosine is negative sine, so sine is just one cosine.
You took the anti.
We're doing antiderivative.
Gotcha.
Okay. The antiderivative of sine is negative cosine, because if we were to go backwards, we would need that negative. All right. You ready for our incomplete substitution?
Yes, we are. No.
Write it down. I don't allow the word stupid in the classroom.
Yeah, Turner. Did you just hear him? No.
I heard stupid. I don't know who said it.
I heard Cole say as well.
Okay, throw me under the bus. That's it.
I was trying to make a blanket statement, so I didn't have to point you out in the crowd. You guys pointed yourself out. Okay, so obviously this is not something that we have a straightforward rule for. We have a composition, okay? We have a composition of 2x minus 1 inside of a radical, and then we also have it multiplied by a little bit of extra, okay? So if you are doing your homework, right, I tell you to look for that composition. Well, that composition is 2x minus 1 being under the radical. So what if we let u equal 2x minus 1? Okay?
Our derivative is
So du would be 2 dx. So 1/2 du equals dx. Yes? We're all with me there. Let's go back to our integral. Dx becomes 1/2 du. 2x minus 1 is u. But then we still have an x that we haven't replaced. What do we do?
no solution. Zudu. Photomath. We said photomath.
Be creative, people.
Zudu.
We don't have to do it again. We have something up there that we can use.
The first column. So equal to x.
Okay. We can write x in terms of u. Everything else is a u. Let's come back up to here. Right? If we rearrange this, we can add 1 and then divide by 2. And that's what x equals? So we can replace x with u plus 1 over 2. on. Why is this so terrible? Okay. So right now this doesn't look really all that nice, but can we make it into a nice problem? You bet. Okay. I'm gonna go ahead and take this 1/2 essentially and take it out with the other one. So I'm gonna make this 1/4. 2 times 2 is 4. And then I have u plus 1 times u to the 1/2. Well, u times u to the 1/2 is u to the 3/2. And 1 times u to the 1/2 is u to the 1/2. Now, I simply have 2 power rules for an antiderivative. Okay? You have to take this and multiply it out so you have your individual terms. So it is an extra step. But once you have that extra step completed, you have some nice antiderivatives. Or I did this.
Yeah, that's what I'm getting.
Okay, and this. It will at the end, yeah. Okay, are we all okay with where we are so far? Oh, okay.
Sometimes it just doesn't
Yeah.
really hit me.
All right, so the antiderivative here would be u to the 5/2 times 2/5 plus u to the 3/2 times 2/3.
Oh, taking the. Okay.
Antiderivative. Should I have changed colors of my marker? I'm sorry. What?
And it wasn't positive.
Okay.
But it's
So
already
now, did I give you a problem with U's? Was our original problem U's? I don't want your answer with U's. So let's change it back. So first of all, what is 1/4 times 2/5?
220, 110.
So 1/10, U was 2x minus 1 to the 5/2. Plus 1/4 times 2/3 is what? 1/6 times u to the 3/2 plus c. Is my red pen writing in purple bothering you?
Yeah. Because I was just thinking, oh, she picked up a new marker. I'm like,
I can't see. There's no marker.
I can change it to any color I want to right here.
Why haven't you done that before? That's sweet.
Have I not done it in here before?
Like, imagine you just have your black marker, you're writing like yellow.
But every time I put it down, it resets. So now it's going to be red. So it's
That's
kind
actually
of
really helpful.
okay. All right, we're going to do one more example. Before we do that, are there any questions about what we did? You guys are awfully chatty for a Monday morning.
We're motivated.
But it's already 4th hour.
It's already 4th hour. We have a 5-day week.
What? I know.
It is going to be a long week, but we'll make it together.
Why did you just choose that?
I know, my wife wrote this one.
Maybe we have 3-day weekend. That's what's getting us through it.
No,
Right now.
Reading
We're a while.
I know, I saw that.
Figures.
And I was like, okay.
Literally
Like,
Friday.
Well,
don't matter.
they.
What's happening in series?
Yeah.
I'll wait to do this problem when it's quiet. Ooh, that worked very quickly. Okay. So do you see how we have composition? Okay. What would be our option for a substitution? Okay. Anytime you have a fraction, you want to leave your numerator for the leftover. Okay? Anytime you have a fraction, you really want to focus on what's in the denominator. Okay? So if u is x plus 4, then du equals dx. Well, that's nice, right? We have some simple substitutions to make here. So our integral would become, let's see, dx becomes du. This is the square root of u. And then in our numerator, we have 2x plus 1. Well, couldn't we write x as u minus 4? Okay. Which means our numerator would be 2u minus 5.
8 plus 1.
Oh, wow.
I was just doing it too.
Are we ready for antiderivatives?
No.
No. Make this look a little bit nicer.
Do it.
2u to the 1/2 minus 7u to the negative half. That's a du. There, that's my du. Oh, I thought you had a question. Questions to hear? This becomes u to the 3/2 times 2/3 times 2 minus 7. This becomes u to the 1/2 times 2 plus c. And then we have to change it back into x's. So we have 4/3 x plus 4 to the 3/2 minus 14 x plus 4 to the 1/2 plus c.
Boom.
Comments, questions, concerns? Tomorrow we're going to do some review for our quiz on Wednesday. And then Thursday and Friday we will begin looking at what an integral really represents graphically when we put numbers on it. Okay.
It was more like.
Area under. So who's that area? Aaron, is that you whispering that?
What?
Now is that the area under the curve?
Yeah.
It's on the floor.
Oh, dang it. That's my own fault.